Next example of change of order. Change the order of integration 0 to a root a square minus x square to x plus 2a fxy dy dx. So I have to change the order. So first draw the figure, and this is the limit on y. So y is root a square minus x square. Means if you solve this, squaring both sides and simplify, we have the equation x square plus y square is equal to a square. This is the equation of circle with center 0 0 and radius a. So first draw the circle with center 0 0 and radius a. So this is the radius a. Now y is equal to x plus 2a, that is x minus y is equal to 2a is the equation of straight line. Y is equal to, write that, y is equal to, yes, x plus 2a is the equation of straight line. Y is equal to x plus 2a. So how we can draw this straight line? Substitute x as 0, we get y as 2a. X as 0, y as 2a. So denote that point that x is 0, then y is 2a. So 2a 0 point. This is the 2a. This is the point a 0, 0a. And this is 0, 0, 2a. 0, 2a. X is 0, y is 2a. And if we substitute y as 0, then x is minus 2a. So on x axis, denote the point minus 2a 0. This is the minus 2a 0, and then draw a straight line passing through this line, these 2 points. Okay, so this is the equation of line y is equal to x plus 2a, and then this x is equal to 0 is the equation of y axis. X is equal to 0 means, and x is equal to a, draw the line x is equal to a, and where it cuts this line y is equal to x plus 2a, the point of intersection is what? So this distance is a, so draw the line passing through point a, that is like tangent to the circle, and so this point of intersection of these 2 lines, so substitute x as a, we have x as a, we have y is 3a, so x is a, y is 3a. So this is the point of intersection of these 2 lines. X is equal to a line and y is equal to x plus 2a. Okay, and this point is 0a, this point is 0 2a. Now this is the shaded region is the region of integration. Now we have to change the order, that is we have to integrate with respect to x now first, because here is the integration is with respect to y first, given is integration with respect to y first, we have to integrate with respect to x first, and that's why take a strip parallel to x axis. But if you take strip parallel to x axis, then the strip if the strip is in this area, then it touches to the circle, one end touches to the circle and another end touches to the straight line x is equal to a. But after this line, what happened? This strip touches to this x is equal to 0 line or y axis. That is, its end, right end touches to the same line, but left end touches to the before this line. After this line, we before this line, this end touches to the circle, and after this line, this strip touches to this line x is equal to 0 or y axis. Again, what happened after this line NB? The strip changes its one end. It touches now to this line y is equal to x plus 2a, and that's why we divide this interval in 3 parts. So draw this line. Okay, this part is one part R1. This part, second part, up to this is R2. So right here, this is wrong. That is here, right? This region up to this CM line, region is R1. So write this R1 at this place R1. This region, that is NBCM, and this region is R2, and this region NBAN, this region is R3. Okay, so divide the region of integration in 3 regions, sub regions. What are that? R1, R2, R3. Now the double integration, the given double integration fxy dy dx is equal to, first write is equal to double integration over r1 fxy dx dy, instead of dy dx write dx dy, plus double integration over r2 plus double integration over r3, and then write this step that fxy x runs from. So in the region r1 x runs from, so one end of this strip in region r1 touches to the circle x square plus y square is equal to a square. So find the value of x. So x square is a square minus y square, and therefore x is what? Plus minus root a square minus y square. So plus a square minus root a square minus y square is the lower limit, and the other end touches to the line x is equal to a. So x is equal to a is the upper limit. Okay, and in order to cover this region R1, we have to move this strip from this point to this point. That is, at this point, y is a, y is 0, and at this point, y is a. So y runs from 0 to a. Similarly, in the region R2, draw the strip parallel to x-axis, and one end of the strip touches to the line x is equal to 0. So x is equal to 0 is lower limit, and the other end touches to the line x is equal to a. So x is equal to a is the upper limit. And in order to cover this region R2, we have to move this strip from this point to this point. That is from point M to point N. And at point M, the y is a, and at the point N, y is 2a. So a runs from y runs from 0 to 2a. And then the third, in the region R2, R3, the one end of the strip, draw a strip parallel to x-axis. Then one end of the strip touches to the line y is equal to x plus 2a. So from this we have x is 2a minus y. So x is 2a minus x is y minus 2a is its lower limit. And other end of the strip touches to the line x is equal to a. So x is equal to a is the upper limit. And in order to cover this region R3, we have to move this strip point from point B to point A. And at point B, y is 2a, and at point A, y is 3a. So lower limit is 2a, and the limit of lower limit of y is 2a, and upper limit is 3a. So this is the final answer. Right? This is the description of this. So already these problems are covered. So double integration over r y by x dy dx. R is the region bounded by x is equal to 2, x is equal to 4, x is equal to 2 line is this, x is equal to 4 is this line at a distance 4 from origin and parallel to y-axis. Y is equal to x is the line passing through the origin and which divides the first quadrant in two equal parts or makes an angle 45 degree with x-axis as well as y-axis. And y is equal to 2x is the again line passing through origin, but it is above the line y is equal to x because its slope is 2 and the slope of line y is equal to x is 1. So y is equal to 2x is above the or obtain any 2 points on this line. So and now the point of intersection of these two lines, x is equal to 2 and x is equal to 4 with these two lines. So that are suppose A, D, C and B. These are the 4 points of intersection of these lines, 4 lines. So we can find their coordinates also. So the coordinate of B are what? B are what? Y is equal to, this line is x is equal to 4 means 4, x coordinate is 4, y coordinate, x and y both are same. So 4, 4 are the coordinates of the point B right here, 4, comma 4 in round bracket. Then coordinate of point C are what? X is equal to 4. If you substitute x is equal to 4, then y is 8. So the coordinate of C point are 4, 8. And the coordinate of A are what? At this A is the point of intersection of y is equal to x and x is equal to 2. So if x is 2, then y is 2. So 2, 2 are the coordinates of the point A. And the coordinate of point D are what? Y is equal to 2x. Substitute x is 2, then y is 4. And so 2, 4 is the coordinate of point D. So write all the coordinates of the points A, B, C, and D, the point of intersection of the given two curves. And therefore, the given in double integration over R, y by x, dy dx is equal to, we have to change the order of integration because we have to change the order of integration. Suppose then if we have to change the order, then take a strip parallel to x-axis. We have to solve this integration. That is, we have to integrate either with respect to y or with respect to x. So with respect to y, integration of y by x is 1 by x, and with respect to x, integration of y by x is log x. Therefore, integration with respect to y as well as integration with respect to x first, both are simple. Then we integrate either with respect to y first or with respect to x first. So here the integration, suppose with respect to y first. So take a strip parallel to y-axis. So if you have to integrate with respect to x first, then we take a strip parallel to x-axis. But if you take strip parallel to x-axis, then we have to divide this interval in two regions, because if you take a strip parallel to x-axis, then it moves to from this point to this, so this point. So in that point A to C, if we move to A to C, then its one end touches to this line x is equal to 2 up to point D, but after the point D, the line or the one end of the strip touches to the line DC. That's why integration with respect to y is now simple, because it is we cannot divide. It is not that is the strip. If we take strip parallel to axis, then from for the covering the region, whole region, the strips both ends touches to same unique straight line, unique curve. Okay, and so suppose the integration is with respect to y first, then write y by x as dy first, then dx next, and then integration limit of y. So y runs from so if we take parallel to y-axis, then it's one end touches to y is equal to x, and the other end y is equal to 2x. So y is equal to x is lower limit, and y is equal to 2x is upper limit. And in order to cover this region, we have to move the strip from point A to B. Okay, and at point A, x is 2. At point B, x is 4. So x is equal to 2 is lower limit. X is equal to 4 is the upper limit. And then integrating with respect to y. So integration 1 by x is now constant. Integration of y is y square by 2. Okay, so from limit y is equal to x to 2x, and then upper limit, lower limit values, and then 3x. Integration is x square by 2. Take 3 as common, and then lower limit, upper limit, and the value is 9. So we also integrate this with respect to x. But if you integrate with respect to x, then we divide this region in two parts, that is R1 and R2, and then write as this integration as a sum of double integration over R1 plus sum of, plus integration double integration over R2. So these problems are already observed. Suppose this problem, okay, double integration over R, y minus 2x bracket square, not bracket square, x square dA, where R is the region bounded by the square mod x plus mod y is equal to 1. So this is the mod x plus mod y is equal to 1. So what is the value of mod x? Mod x is either plus x or minus x. Similarly, mod y is plus x or minus x, plus y or minus y. So if we take both signs are plus, then x plus y is equal to 1. This is the line x plus y is equal to 1 passing through the point 1, 0 and 0, 1. Okay. So you can find 2 points on the line. Suppose the x plus y is equal to 1. So if we substitute x is 0, then y is 1. So 0, 1 is the 1 point. And if we substitute y is 0, then x is 1. 1, 0 is the 1. Suppose x is negative. So minus x plus y is equal to 1. So this is the line. Because if you substitute y is 0, then x is minus 1. So minus 1, 0 point. And if you substitute x is 0, y is 1. So 0, 1. So this is the line minus x plus y is equal to 1. Then if you take x as positive, mod x as positive x and mod y as minus y, then x minus y is equal to 1. So this is the line x minus y is equal to 1. If you substitute x is 0, y is minus 1. So 0 minus 1. And if you substitute y is 0, x is 1. So 1, 0 point. And this is the line x minus 1. And if we take mod x as minus x, mod y is minus y, then we have minus x minus y is equal to 1. So this is the line minus x minus y is equal to 1. If you substitute x is 0, then y is minus 1. And if you substitute y is 0, x is minus 1. So minus 1, 0, 0, minus 1, these 2 points. And the line passing through these 2 points is x minus y is equal to 1. So mod x plus mod y is equal to 1. This square is this. Okay. So the square bounded by the 4 lines, x plus y is equal to 1, minus x plus y is equal to 1, minus x minus y is equal to 1, and x minus y is equal to 1. The square bounded by these 4 lines is the square mod x plus mod y is equal to 1. So this is the region of integration. This is the region of integration, that is A, B, C, D, E. Okay, and now we have to integrate this over this region. So take strip parallel to either integrate with respect to x first or integrate with respect to y first. Suppose we have to integrate with respect to x first. Then this given integration is double integration over r y minus 2x squared dx dy, right? Dx first and then write dy. But now this integration is divided, this region is divided in two region, r1 and r2. Why? Because if it takes strip parallel to x-axis, then the strip up to this line AC, one end touches to the line a minus x plus y is equal to 1, and another end touches to x plus y is equal to 1. But after the line AC, the strip touches to left end touches to another line, and right hand also touches to another line, and therefore we divide this region in two parts, in two region, r1 and r2. R1, the above region of AC line AC or x-axis is the r1 region, and below the line AC the region is r2. And now this given integration is equal to double integration over r1, double integration plus double integration over r2. So, and then this first in region r1, we have to write the first limit of x. X runs from what to what? So x, in order to write the limit of x, consider this strip parallel to x-axis, and its one end touches to the line minus x plus y is equal to 1, and therefore x is what? X is minus x is 1 minus y, and therefore x is y minus 1. So y minus 1 is lower limit of x, and the upper limit is what? X is equal to 1 minus y is the upper limit, 1 minus y. And in order to cover this region, we have to move this strip from this point to this point. So at this point y is 1, and at this point y is 0. So 1 to 0 or 0 to 1, right? 1 to 0 or 0 to 1 as a limit of y. So plus the region R2, one end of the strip touches to the line a minus x minus y is equal to 1, and therefore value of x is what? Minus x is 1 plus y, and x is what? Minus 1 minus y is the lower limit, minus 1 minus y. Here is the minus 1 minus y is the lower limit, and from this equation other end of the strip touches to this line x minus y is equal to, so x is equal to 1 plus y is the upper limit, x is equal to 1 plus y is the upper limit. And in order to cover this region, we have to move this strip from this point to this point. At this point y is 0, at this point y is minus 1. So write minus 1 to 0 as a limit of y, or 0 to minus 1, minus 1 to 0 or 0 to minus 1, and then we have the answer. If you have negative answer, then write the positive answer. So this is the, that is now the simple integration. Integration of y with respect to x first is, y is now constant. The integration of y is y into x, y into variable, and then x cubed by 3 as the integration of x square. Then lower limit, upper limit. Similarly here the y x 2 by 3 x cubed by 3. Then lower limit value, upper limit value, we have this. Now integration is from 0 to 1 here, and this is minus 1 to 0. Then integration of this bracket with respect to y is what? Now minus 4 by 3 is constant. Minus 4 by 3 integration is minus 4 by 3 into variable. Now variable is y. 6 y square by 2 y cube by 3 y raised to 4 by 4. Right here 4. It is not 3. It is 4 by, yes, 4 by 4 get cancelled. So this divided by 3 is correct. Similarly integration with respect to y. Then value at the upper limit minus value at the lower limit. We have the minus 2 by 3 answer. So these problems are problems of change of variables. Already these problems are discussed in the previous lectures. So all the problems of the change of variable, change of order, and simple double and triple integrations are covered and communicated with you. Its notes are communicated with you through WhatsApp group. So write all the notes and solve all these exercise problems. So here the syllabus of second paper, first paper, that is calculus of several variables, is over. So solve all these exercise problems and maintain your assignment notebook.